Hello and welcome to Miss Sweeney's room here on a Friday afternoon. We have a cube root example on the board. I know I've gone through this in class. However, it seems like there's still a few people that are struggling with this a little bit, and for good reason. It's a pretty challenging concept. You're so used to square roots and handling them, which sometimes are challenging enough already. So handling cube roots can be, even more of a challenge, and especially when it comes to the variables. Okay, so I wrote 4 different variables in this problem, not to make it such a hard problem, but just to expose you to all of the different possible scenarios you could have. Because with a cube root, it kind of all depends. If the exponent on each variable is less than this index of 3, then you can't do anything with it. That's going to stay underneath the radical symbol in your answer. So the k and the n both, k to the first and n to the second, they're going to stay underneath the radical in your answer. They're just there to be annoying, all right? Just leave them there, all right? But the m to the third, you're going to do something with that. In fact, if this exponent were any multiple of 3, you would have something very nice happen, okay? And then p to the 25th, you'll have something happen to that as well. If this exponent is larger than this index, you can simplify it, okay? The only ones you can't are the k and the n squared, all right? So, and that is 2. Doesn't really look like 1. I'm going to make it look like 1. All right. Now, let's first start by picking everything apart. The first step really is to split this up into several cube roots. Now, you don't have to do this. You don't need to show any work. Like on my answer key, I would immediately know the answer. And I'll show that to you actually to start. Here's the idea, okay? You want to break out the 72 using a perfect cube that goes into 72. You got to be familiar with your cubes. 8, 27, 64, so on and so forth. 8 times 9 is 72. I know the cube root of 8 is 2. So we have to take out that 2, and we're left with the 9 inside the radical. So in the answer, I'll have a 2 outside, because the cube root of 8 is 2, and a 9 inside. So I'll have a 2 outside, and eventually I'll write the cube root here to leave myself some room. A 9 inside. Okay, we just handled the cube root of 72. Now, the cube root of k, again, I can't do anything with that. The cube root of m cubed is just m, okay? It's just m to the first. Whenever this exponent underneath the radical is a multiple of that index, you just straight up divide this by this. 3 divided by 3 is 1, and that tells you the exponent on this variable on the outside. So if it were m to the 6th, you would have m squared outside. If it was m to the, 33rd, you'd have m to the 11th outside, and so on and so forth. You just divide this number by this one to find out the exponent on that variable in the outside. Okay? It is a multiple of this, so that means you will not have any m's underneath the radical. If this number is not a multiple of this, then you will have some m's underneath the radical. Got it? All right. N squared, we could do nothing with that. That's going to stay there. Now, the cube root of p to the 25th. This is where it gets a little tricky, okay? The steps you want to use are you want to find the largest multiple of 3. The largest multiple of 3 under 25. And you should know your times tables. That would be 24, okay? So p to the 24th times p. If you think about this p to the 25th as p to the 24th times p, you're left with just a p underneath here. All right? P to the 24th, 24 divided by 3 was 8. Okay? So we'll have a p to the 8th on the outside. All right? So that's the hard part, that this became p to the 8th. I thought I had you there for a minute. P to the 8th root p. Okay? P to the 24th, the cube root of p to the 24th, like I said, you would just divide 24 by 3 and get 8, right? Well, okay, so you have that, but then you had 1 p left over to get to the 25th. This is the answer, all right? This here is the answer. So I guess because of time, I'm not going to have a chance to show you visually with a marker every step here. But I think speaking it out, all right? I think if you have to rewind this, that's fine. But again, you want to consider every one of these separate. So you really, theoretically, you split up into 5 different cube roots and simplify each one separately, and then put it back together at the end, okay? Again, from 72, I used 8 times 9. You couldn't use 36 and 2. Can't do that. It's not a square root, okay? 36 is not a perfect cube. So you got to get that out of your mind. You see a root symbol, you think, oh, 36. No, it's not a perfect cube. You've got to use numbers that are perfect cubes, right?